Okay, I think I'm going to make a start. I forgot my pointer, which is a bit annoying because I like standing a bit away and pointing at things with the laser, but it's not going to be possible, so I'm going to have to stay around here and click. So I'm just going to move this chair around. So hello everybody. It's the last day, it's after lunch, so I'm actually surprised that there are people here. Especially after last night, because I've been told it was quite a long night. I mean, I went to bed at a moderate time. I don't know what time you guys went to bed, how much you had to drink. I hope you had a good time, that's always good. But yeah, because of that, because of the risk of a post-lunch crash plus potential hangover or anything else, or just being tired because of 4 days of conference, I want to try to do this a bit interactive. I want to make this a bit of a conversation. Obviously, I have a lot of content to cover, but I'd rather cover less content and have an interaction with people and find something useful out of this than cover all the content and have a lot of sleeping beauties at the end of it. So yeah, let's just keep it entertaining. Right. Having said that, let me introduce myself a bit. So my name is Marín Pérez. I work for a company called Mendeley. I don't know if you've heard of it. If you do research of any kind, you probably have. You may even use the tools. I also work for ACCU. I'm a Java editor, so I write news about Java or JVM related things. And I also do collaborations every now and then with O'Reilly Media. I have a report that it's about to publish in about a month from now, probably. When I have time, that is not that much, I also run, or help run rather, the London Java community. I don't know if you heard of it, but it's one of the biggest Java user groups in the world, and in fact it has a place in the Java Standards Committee, so it's a big thing. Previously I have worked at JP Morgan and OpenBet. JP Morgan you probably have heard of because it's quite a known bank. OpenBet you may not. OpenBet does software for betting and online gaming companies. So for instance, William Hill, Coral, Paddy Power, etc. are clients of OpenBet. When I was working there, we did software for these companies to help manage the stuff. Anyway, I'd like to start by checking the audience, see what kind of population we have here. So I'd like to know what kind of technologies we use here. For instance, who is a C++ developer? Who is not a C++ developer? Okay, I was going to go on other languages, but it might be easy just to ask, what do you program?
Java.
Java, okay, yes, thank you. I salute you. Nobody else Java? Okay, good. So I am mostly a Java developer. I've done also PHP, C#, and Ruby, but I mostly do Java. What I'm going to talk about, which is continuous integration and continuous deployment, actually I think the ideas are applicable to any language, although unfortunately, because I'm a Java developer, then the examples that I have here are about Java and Java technologies. So what I'm going to try to do is, when I talk about these things, I'm going to try to comment parallelisms or other tools that we could be using in C++, for instance, here. So anyway, I said continuous integration and continuous deployment. I've noticed that in the literature and in talks, etc., different people seem to mean slightly different things when they talk about this. So I'd like to establish a baseline and say, when I talk about continuous integration and continuous deployment, this is what I mean. So for me, continuous integration is the idea of you have your code, and every time you make a change and you commit that change to the repository, then you assemble everything, you compile, you run your tests, and you package the stuff. That's what I understand as continuous integration. When I say continuous deployment, then it's basically the same thing, but taking it one step further, which is you get that package that you created and you release it to a test environment or to production, so something like that. Or at the very least, you make a releasable package, something that you can actually put in production whenever you want. It's just something that is ready to go live. About the talk is going to have 3 parts, mainly. The first part is going to be the why. What I mean by why is I'm going to be talking about how to make continuous integration or continuous deployment fast. And obviously, when you talk about how to do something fast, the first question is, why would you need to do that? Why are you going to spend the time and the effort in doing this? So I'm going to explain a few problems and or opportunities that are going to come up when you think about continuous integration and continuous deployment being fast or slow. The second part is going to be about how you do that. And the basic idea is going to be, if you have a big build that is represented by this big ball on the left, then the basic idea is you break it down into several independent but interconnected builds. So then the key thing is, whenever you make a change, you only rebuild and retest the bits that you actually need to rebuild and retest. And everything else, you just reuse pre-compiled stuff or pre-built stuff that you had before. Now, when you do this initially, it's going to be kind of obvious what you need to break down. If you only have one build, then clearly you have to break that build. When you have two, then you probably get the biggest of the two, and so on and so on. But then at some point, you're going to have a lot of them, and you're going to have a complicated network. So then, if at that point your build's still slow, knowing what to tackle next is not going to be that easy to decide. So then what I'm going to talk about next is where to go from there, which is how to decide when you have this complex network of builds, how to decide what you're going to break down next. All right. One of the reasons I decided to break it down in three is because some people may have different circumstances. Maybe you have an idea, you have an intuition that you need to make your continuous integration faster, but you don't know how to express that to your manager. So maybe the first part is going to help you with that. If you already have an idea of that, then maybe the second part is going to help you how to break down things. And if you already know how to do that, or maybe you already have that, then the third part is going to help you decide how to progress from there. So let's go to the first part. Let's begin with another little survey. I like doing surveys. So who has continuous integration and or continuous deployment at the moment? Okay, mostly everybody. Of those that you do have, which ones have a continuous integration build that takes 10 minutes or less to run? Okay.
Yeah, both. I mean, if we have many of them.
Oh, okay, okay. Okay, 10 to 20 minutes, 20 to 30 minutes, more than 30 minutes, more than 1 hour, more than 2 hours? How long?
4 hours.
4 hours. Okay, that's good. That's good. This is why we have I have this kind of talk, because I know there are people here. This kind of problem. What was that?
That's why.
Exactly. Good. I'm glad you're not sleeping. So here's the thing. I'm going to present an example. This is what I call a super application. It doesn't matter what it does. What matters is that initially it's a small thing. It has just a few tests. It builds in 4 minutes, and it produces a package that, in this case, is a WAR file. For those of you that are not familiar with WAR files, that's a way to package a web application in Java. Then you put in a web application container, and it runs things. But that doesn't matter. What matters is, initially it's a small thing, it's a manageable thing, but then obviously you're going to build more features into it. So then it's going to get bigger, the build time is going to get longer, and it's going to get bigger, and it's going to continue like that. So that eventually you get to the problem of size. Why is size a problem? As I said, some people may know already, some people may not, so I'm going to explain a few things of why this is a problem. The first one is you have slow feedback. If I make a change, that goes to the build. If I break something, if it takes an hour, then it's going to take me an hour to know. Well, maybe it doesn't take me an hour. It's going to take me an hour to know that everything is fine. It might take me less to know that everything is not fine if it breaks, because hopefully it will not break at the very end. It will break at some point in the middle. But still, it's a slow feedback. I need to be waiting there for that to be completed to know that it's okay. The problem with that, if it does break, it's going to mask all the issues. If it's broken, and then somebody else continues making changes, the build's still broken. And when that happens, I don't know if it is still broken because of the initial change or because of some further changes. But what's more, let's assume we have a build that takes 1 hour, and I make a change and it breaks. Now, on average, it's going to break half point, right? So sometimes I'll be lucky, it will break at the beginning. Sometimes I will not be that lucky, it will break into it. So on average, it's going to take half an hour. Okay, so I make a change, half an hour later, I see a red light. It's broken, I need to fix it. So I do my fix, and I put it. Half an hour later, still red. Now, what was that? Is it because my fix didn't fix the problem? Is it because my fix fixed the problem, but it broke something else? Is it because my change is completely fine, but during that hour that the build has been read, somebody else has made a change that has broken the build? I don't know. So then it gets to a point where, I don't know if any of you have been in this situation, but you get to pretty much development paralysis. Have you been to a situation where the build is read and people are trying to fix it and it doesn't quite get fixed, and then somebody stands up and say, okay, everybody, stop making changes. I'm going to fix the build. Once the build is back to green, then you can carry on making changes. Has anybody been in that situation? Exactly. It happens. And it's not pleasant, is it? It's not pleasant to be there going, I have some changes, I can't commit because the build is red. Okay. Now, that's just problems. Sometimes it's not really about the development process, it's about some of the things, for instance, contractual problems. Does anybody have SLAs, for instance, on bug resolution? Oh, you're lucky. Oh, there's one over there. Good. So sometimes what happens is you may have a contract that says if there is a bug, a critical bug, you need to fix it within 3 hours. Right, if your build takes 1 hour, that means really you only have 2 hours to fix the bug, because the last hour is going to be just creating a new version. So then that's going to be another restriction that a slow continuous integration system applies to you. And then finally, we're beginning to see some missed business opportunities because of the slow builds. I was talking to a friend back in London, and he was telling me about a customer they had. It was a fashion retailer. And they had made a few experiments, and they realized that if, imagine there is some X Factor show or whatever, there's something on TV, and then some celebrity appears with a particular coat or shoes or handbag or anything. If they manage to change the website, to change the landing page of the website, to show that piece of clothing within 1 hour, and not just showing it, but also kind of doing a theme out of it, doing a user experience that is precisely on that particular piece of clothes that has appeared on TV less than an hour ago, they make money. They actually sell more of that, but it has to be quick. It has to be within 1 hour. If they take more than an hour, then that effect of the peak sales fades out. Now that means that if you need to do it within 1 hour and your build takes 1 hour, you're losing that money. So you need to have a quick build so you can do these changes as things happen on TV and be reactive and get the customers to get that impulsive feeling. So,
But that's the kind of situation where it should be more configuration than doing a build.
it depends, because the thing is with this, what they find out is that it's not just having a particular product appear on the landing page, it's more doing an experience that is around that product. So then that means that they actually need to do some programming. For instance, they might need to do some animations in JavaScript to, I don't know, it depends a lot on the product, but they need to personalize it. They need to make it vary about that particular product for that to work. So knowing that it's a problem, when I face this problem myself, then I try to talk to people around to see how they try to fix it, because obviously this doesn't happen only to me, this happens to a lot of people. And I found very different ways people manage to approach the situation. The first one is to just ignore it, to say, look, the build is low, that's life, suck it up. I wasn't particularly happy about that. Another thing that I saw people doing is they do what I call partial continuous deployment or partial continuous integration, which is, okay, we have a build, we have a set of tests. We have some tests that are rather quick, for instance, unit tests, and then we have some of the tests that are very slow, typical integration tests. You need to spin up a database and then populate it with data and then run the end-to-end. That's very slow. So what they do is, on continuous integrations, we only run the unit tests, the quick things. And then what we do is we have a scheduled thing at night that is going to run the slow things. That sort of fixes the problem of the immediacy, the having quick feedback. But then that creates another problem, which is if your change doesn't break the unit test, but it breaks the integration test, you will not know until tomorrow. So then you might be doing a lot of changes after that, and then tomorrow morning you come in with a bunch of broken tests and you go, okay, which of the many changes that anybody in this team made yesterday is the one that broke the build? So basically just delaying the problem. Another solution that I've seen is kind of similar. It's a phased continuous deployment. So what you do is, okay, this is my system. Doing continuous deployment on this system takes very long because of all the problems that we mentioned. So what we're going to do is we're going to break it in parts, and we're going to do continuous deployment only in the individual parts. And then maybe once a month, then we actually get the parts together and see what happens. So sure, the different parts are going to be quicker, and you're fixing the problems for the individual parts, but not for the whole system. In fact, for the whole system, you're slowing the problem even harder, because then if you break something, you're not going to know today, you're not going to know tomorrow, you're going to know in a month from now when you actually put the different pieces together. So again, not quite the solution that I was looking for. And then the one that I found the funniest is the test deprecation policy. You know you're in a proper situation because of when they come up with policies to fix a technical problem. The test deprecation policy is you do an analysis of your tests, and what you do is you check which ones statistically never fail or fail very rarely. And what you do is, well, if they never fail, that means this part of the code is very stable, which means probably we don't need to test it anymore, so we can just remove those tests. I don't find that a very safe choice, to be honest. That's a bit like saying, you know, these roads, they seem to be very safe. We don't have many accidents in there, so we can tell people to forget about safety belts or helmets because, you know, people don't have accidents anyway, so we don't need the safety measures. So I didn't like that option either. I don't know if you have any other examples of how people try to tackle this problem. Any other thing that you'd like to share? Okay. Yes?
So there's an option on the data CD, the component build, that also have like the integration coming, trailing that every time. You don't defer the integration till later when you build that.
Mm-hmm.
The test is still what it is. The build and the packaging can be minimized.
But then you're still running everything.
Yeah.
So then if you have a long build, it's still going to be long, I guess. Yes?
So we have a fairly long compile time, and we would make it drop on its own, which in the end triggers the next drop. So you can get feedback on the compilation while the test will be run later, but immediately after. So I kind of like split up the build chain into parts so you get feedback earlier. So at least you know it's not compilation error, then you know it's not test error, then you know. But in the end, the whole chain takes still long.
Yeah, exactly. So that's the good thing about those is you can get the negative feedback earlier, but the positive feedback, the one that says, okay, everything is fine, you can go ahead, you can't make that any quicker that way. So this is when I'm coming. What I want to do is split things up. Now this is when I'm going to start talking about particular technologies, so I like to try to explain them a bit before, just so we have a bit of a background. Does anybody know Maven? Obviously the Java developer. Okay, for those who don't, Maven is basically a build tool plus dependency management system. So it's a bit like Make, but adding also dependency management. So you can indicate in your Maven config file, you can say this project depends on these particular libraries, and you indicate the version of the different libraries that you want. And then Maven will bring them up from public repositories to you. So you don't need to do anything. You just need to declare your dependencies. TeamCity is a continuous integration server. Who knows TeamCity? Okay, who knows Jenkins? Okay, good. So it's basically the same thing as Jenkins. It's just a different one. There are others like Bamboo or Circle, or there is this Microsoft one called, is it Source Foundation? Foundation server, thank you. Yes, so it's basically the same thing. I'm going to be referring to TeamCity, but the features that I'm using in TeamCity are simple enough. I'm sure they exist in any other continuous integration system that you can think of. Artifactory is a library repository, basically. It's very tightly linked to Maven. So I've said before, in Maven, you can specify your dependencies, and then it will download them for you. It will download them from an Artifactory server, for instance. Now, there are public ones. The most famous one is Maven Central, and that's where Maven, by default, will try to get the dependencies from. But you can have your own Artifactory server for your company, where you put your own libraries there with your versions. And then Subversion, I'm assuming everybody knows what Subversion is. Anybody who doesn't know Subversion? Good. Again, if you use Git or CVS or anything, it doesn't matter, it still works. I'd like to start with, by giving credit to a person called John Ferguson Smart, because the first part of the methodology that I'm going to explain is based on a talk of his. That's the name of the talk. I recommend it. It's an hour long, so that's why I need to do it very summarizing here. If you have a phone that's a QR code, that might be easier if you'd like to take a look at that for later. I'll wait a bit just in case anybody wants to take a picture. Okay, so this is basically John's approach. Now, the main problem is, I've talked about Maven, and I use Maven because that's one of the most popular tools for building and managing dependencies in Java. But the problem is, Maven wasn't built for continuous deployment. And that, to my knowledge, applies to pretty much any other build tool that you have out there. They haven't been thought for continuous deployment. The way Maven builds is, you can specify the version of the product that you're building. So for instance, here I'm working on 0.0.1, and I call it Snapshot because I'm still working on it. And what happens then is I can keep on making commits to this thing, and I can package that and I can publish it to my Artifactory server, and that's going to be fine because it's a snapshot. Snapshot is understood to be a work in progress bit. But the idea is, once I'm ready and I want to release, then I make an actual version of it without the snapshot bit, and I can publish that to Artifactory. But once I publish that to Artifactory, I cannot publish another library with the same version number. Artifactory doesn't let me do that. They say, no, you've already published 0.0.1. If I were to publish something else, then it has to be a different version. The problem with that is that this is a mindset that means I'm going to be working on it, and once I'm ready, I'm going to make a release. I'm going to deploy. That is exactly the opposite of doing continuous deployment, which is every time I make a change, I go through the whole pipeline and I deploy, right? If we think of, for instance, Make, does people use Make? What do you guys use for your build? Make. Oh, CMake. Is that different from Make? Okay.
It's a make for make.
It's a make for make. Boom. Good. Pardon? MS Build. I like MS Build actually, but I don't think MS Build can manage versions, or does it download the dependencies for you? No.
And we also generate the MS Build repository.
Oh, okay. Okay. So anyway, the problem here is, as happens with Make and CMake, etc., is This hasn't been thought for continuous deployment. It has been thought for kind of event deployment. It's like, now I'm ready, now I'm going to make a release. In Maven, people tend to use the release plugin when they want to work this way. So the first recommendation that John on his talk does is do not use a release plugin because it hasn't been thought for continuous deployment. Instead, we're going to do a trick and we're going to play with the versions plugin ourselves. What we do is, in my build, in my config file, I have the version number of the library that I'm building. So what I do is, in the continuous integration server, every time I run a build that is the result of a commit, I'm going to update the version number, which means every time I'm doing a build, that's a completely new version. Typically, what we can do is, if we have if we typically work with 3-digit versions, then we can add a fourth one, and the fourth one is just a build number, right? If we want to specifics with Maven, you can do that just by calling the plugin, but we'll see that in a minute. So, as I said, the first thing we do is we set up a new version number for the particular build that we're doing right now. The second thing we do is we actually run the thing, which is the Maven deploy instruction that we have here. Then we get that new library that we have, new version of the library that we have created, and then we publish that into the Artifactory so it's available for other people to use. And finally, we get the config file where we change the version number, which in the case of Maven is the POM file, it's called the POM file. We get that and we commit that to the repository, which means then that that new version number is going to be stored in our code base. And if anybody downloads it, then we know we're working now with this particular version. Okay. Sure.
Is that necessary config between Artifactory or version?
Both. So the build binary will go to Artifactory, but then the config file where we have saved which version we're building, that will go to source code.
So how do you avoid that starting another build?
We'll see that later. Right, so going into a bit more detail, I don't know how useful this is going to be to you guys, given the fact that this is Maven, but well, we can still take a look. Actually changing the version number, in Maven, you do it by calling that particular command. In make, you can do, I guess, any text modification for your config file. There's a nice trick that you can use because we are generating new version numbers automatically. If you still want to handle kind of generic version numbers, for instance, I'm working in sort of my 1.2 major release, even though each individual build is going to have its own build number. Then when you can do in systems like TeamCities, you can create a general parameter, that is, for instance, a general version. And when you can do here is whenever you set up a new version, you use that parameter followed by the build number, which means the full version number is going to be different on every build, but all of them are going to start with this value that you can set, and you can change whenever you want to. Okay. Second step, as we said, is just do a build, which in Maven you do it that way, make or cmake, and you do whatever command you're using. And then you commit that to the repository. This is how you do it in Maven. Basically, you can use a plugin to commit changes to repositories, and then you indicate where your user and password is, etc. If you're using if you're using make, then I guess you can just add a step to call git or subversion or whatever you're using, and make the change, to commit the change of the config file to the repository. And then finally, in our case list, it looks like 2 steps in TeamCity. The first one to update the version number, and the second one to build and deploy everything. And that's what it looks. And then with that, the effect that you have is whenever you make a change, that triggers a build and it creates a new version. When you make a different change, that triggers a new build and it creates yet another version. When you do another one, another version, etc. And now, these versions, you can choose to deploy to production straight away or to a test environment, or you can just save them, and then whenever you want to do a release, the only thing you need to do is get that and put it. And that's one thing that works. Now, here's the problem. How do you scale it? All this works for one build. We want to have multiple of them. What I want to do, basically, is I want to split it. The way I want to split it is, if that is initially my application, the super app that I was showing at the beginning, I want to break it down into two for the beginning. For instance, in this case, I can break out a backend component. This is a jar file. A jar file is just a way to package libraries in Java. So I guess this is a compiled library. In C++, this would probably be a DLL or a .o object, anything like that. It's a compile object that you can save and you can reuse later. And the idea is, once I have separated this, what I want to do is, if I make a change to the backend, then I'm going to run the build, I'm going to create a new compiled object, I'm going to store that new compiled object, and immediately after that, I'm going to trigger a build of the super app that is going to consume that object that I just created, is going to compile whatever is in this particular bit, is going to run the test, and then it's going to create the final executable. However, if I make a change to the super app module, I am not going to rebuild the backend. I'm just going to consume the existing compiled object that I have in my Artifactory, and then I'm just going to compile and run the test specific to this particular module, and then I'm going to create a new version of the executable. Now that means that since I am updating the version number of each module on each build, then each different module is going to have different versions. And now the complicated part is, when you indicate here that you have a dependency on that module, in your config file, when you need to indicate the version, what version do you indicate? Because that's going to be changing continuously. In Maven, you can do a trick, which is you just use latest. That's a keyword. And basically what Maven does is it goes to the repository and it finds whatever the latest version is, and it uses that. That sort of works. Maybe you can implement something like that in your dependency management in Make. Is there any way to manage dependencies for C++? Any particular tool that you can use?
Well, CMake will build up a tree.
Okay.
Or you could do it manually.
Or you could do manually.
Manually you can write your own program.
Yeah, you can do a script probably of, it's just a matter of finding what versions you have available and picking that one and downloading, right?
Yeah.
Pardon?
You can ask CMake to find the version that you want.
You can ask it to find things for you. Okay. So I'm talking about Maven here, Maven there, Maven downloads, etc. But I am hoping there is a way to do this in C++ as well, so you can find this useful. Yes?
We do it like this using Gradle and learn factory C++. Works exactly the same way.
Oh, okay. Brilliant. So yeah, you can use the latest, and then from the point of view of compiling, that works. Now, from the point of view of CI, in TeamCity, you can define what is called snapshot dependencies between builds. And what this is telling TeamCity is that when one build has a snapshot dependency on another one, then it's telling it, whenever you need to build this, you need to make sure you have the latest of the other one. So for instance, in my executable, I would define a snapshot dependency of the backend. And the result that would have is, well, I can also say trigger on changes of the snapshot. So what that makes is, if I make a change to the backend, then TeamCity is going to detect that there's a dependency, and it's going to add both builds to the queue. It's just that because it knows it has a dependency, it's going to build one first and then the other one, right? So we can see that here. If we have that dependency snapshot defined, when I make a change in this side, then TeamCity knows that this one has a dependency on that, so it's going to add both builds to the queue, but it's going to wait until the first one is cleared before it starts the second one, which is kind of the effect that we want. What we want to do is, if I change the backend, I run both. If I change the executable, I only run that one. Okay. Does anybody ever have to rebuild all the versions, for instance, to fix a bug or anything like that? Right, that happens. If you do that, the latest trick is not going to work. Because if I need to rebuild last week's version, if I get that from the repository, the config file says latest. And if I build that now, it's going to be the latest now, not the latest last week. So that doesn't work. To make it work, we need to make this slightly more complicated. So in the config file, instead of just using a keyword, we need to indicate the exact version that we depend on. So that gets recorded in the repository. So in here, I am depending on 1.5.3.1. And if I save that in the repository, if a month from now I need to rebuild it, when I get it out, I have full information about what dependencies and what version of those dependencies I need to build this. And the way we manage this to update it is, in the case of Maven, there is a command to update your dependency tree, to update the dependencies to the latest available. I'm assuming this wouldn't be very difficult to program in any other scripting language or in CMake, etc. Basically, what you need to do is you do a scan of your own dependencies, then you go to your repository, to your Artifactory, and check what versions are available. And if you realize that any of them has been updated, then you update your config file to refer to the newer versions. And then at the end of the process, you're going to commit that file to the repository anyway, so you're going to record those new version numbers. With that, you have kind of a template process that you can use to break things down. Ooh. Right? So then initially I broke it down in 2, but then I can break it in 3. I can maybe add a module for data model. And then maybe I can break it down further. I just keep on using this thing, keep on using the dependency pattern and just the scripts to update the versions number of the build of the module that I'm building and of the dependencies. And this way, I can just keep on breaking it down and keep on growing, right? So is this something that you guys would consider, or do you guys have anything similar to this? Yeah? No? Yeah? 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 It doesn't work. Not quite. There are a few problems. The gentleman at the back mentioned one of them before, and we can try to find them together. One of the problems that you're going to face if you try to do this is the problem of the infinite trigger. I'm mentioning this one first because he mentioned it before. Now, let's follow what's happening here. I'm making a change to Subversion. That change is triggering a build. And after that build finishes, I am deploying the new compiled binary to Artifactory, and then I am updating the config file into the repository, which means I am making a change, which is going to trigger a new build, which is going to deploy a new artifact, which is going to do the config file, and I guess you're familiar with the concept of an infinite loop. Right. Here's where it starts to get tricky, because again, all these tools, the continuous integration system, etc., they weren't actually thought for continuous deployment in a scaled way or multiple builds. What you need to do in this case is you need to tell TeamCity or whatever build system that you're using not to trigger builds from the user that you're using to change the config file upon build. Otherwise, it's going to be triggering itself. So provided the changes that you're making to the config file are made with one particular user that nobody else in the team uses, then that's going to be fine. In this case, our user for the commit was called the build agent. So we just tell TeamCity, if you see a commit by build agent, don't do anything, ignore it. What happens then is that TeamCity knows there is a change, but it's not going to do anything with it. It's just going to tell you, I have a pending change here, but it will stay like that, it will stay pending. Okay, so that's one problem fixed. Can you guys think of another problem? Yep.
What if someone push between the commit of the build and the first commit that triggers the build?
Yes. Okay, so I'll go to that one straight. I'm going to change the flow of the presentation. No, actually, I'll do that one later. I think it's easier to explain if we do it in order. But yeah, good point. I'm going to go to that one. I was hoping somebody would come with this one. Yes? Sorry, I thought somebody said something. Anyway, the second problem that we're going to face is the unnecessary rebuilds. Let's think of a scenario of, I built the backend before, and because of this trick that we're doing to avoid or to prevent commits from the build system itself to trigger further builds, then we know that it's a pending thing over there. Okay, and then we make a change to the final build, to the executable build. Now in theory, what we wanted to do is, since we're making a change here, we don't want it to build this. We just wanted to get the latest available binary from Artifactory, consume it, use it here, and produce a new executable, right? Now what is going to happen instead is that TeamCity is going to see that you want to build this, and this has a dependency on the backend, but you don't have the latest version of the backend because you have a pending change. So then TeamCity is going to build this one, and then only after building this one, it's going to build the other one. Which means that we did all this, so we don't have to rebuild the dependencies, and it turns out that we're rebuilding the dependencies anyway, which is rather unfortunate. It's kind of firing back at us. So again, this is when you need to trick TeamCity. What we did was, since we cannot stop the build from happening, we just make a fake build. So at the beginning of the building, we have a new step, which is checking whether we actually need to run this or not. And that's a very simple script that basically does this. It checks who the last committer was. If it's the build agent, just don't do anything. If it is not the build agent, then that means that that's a build that you need to run, then go ahead. And then going technical, the way we actually signal that we don't need to build anything is we create an empty file called skip build. And then in Maven, we create what we call a profile, a configuration, that activates whenever that skip build exists. And then what we do here is we just configure all the different steps to be skipped. So it doesn't actually do anything. Maven will be invoked, but then all the steps in Maven will be skipped. It's a bit of a hack. It shouldn't be that way, but personally, I didn't find any other way to make it work. So what happens when you do that is that, yes, you make a change here, and yes, TeamCity, because of that change, is going to trigger a build here, but then that build is going to clear without doing anything. The pending flag is going to disappear, and then it's going to run your build. The good news is the next time you make a change there, you don't have the pending flag anymore, which means you're not going to have that problem. So that fake build is only going to happen once. Unless I make another change in the backend, then it's going to have the pending flag again, and then I'm going to have that effect again. Fortunately, it's not a very costly thing. So here's an example of the system where I set it up. The build on the bottom is a real build. You can tell because it has a report of how many tests were run and passed. The build on the top is one of these fake builds. It just says success because it didn't actually do anything. It didn't compile, it didn't run tests. And you can see the duration is significantly shorter. So you are kind of rerunning some builds that you don't want to run, but they are shorter and only happen sometimes. It's a bit of a side effect of having this system. Yep.
I assume like Maven should check dependencies to send to rebuild. You just go through everything, say, oh, I will rebuild everything.
What was that?
Like when you trigger the rebuild of the first one, like it's already built, so we already have the file built, and when you trigger the build, like you see, just see dependency already compiled, and say, oh, it just goes through the whole dependency but doesn't build anything. You see what I mean? Or?
No, sorry. Can you repeat that?
Like you already compiled before, like you jar file. So you don't need to think to recompile it, and the dependency already, like jar file is already good, so at the end the dependency are already respected, so it should be super fast.
True, but then you are recompiling and you're retesting, which is precisely what you want to avoid.
Okay, for the retesting.
Yeah. So what I like to do in this case is, if it is something that I have built and tested before, then I don't want to do it again unless I really have to. And I only have to if there has been a change that affects it. So in this case, the change that I make here doesn't affect that, which means I shouldn't have to rebuild this bit. That's what I want to avoid. In this case, it's only 2, so it's not going to be a big thing. But if you imagine a much longer pipeline, then if I'm making changes at the end of the pipeline, I don't want to rebuild any of the stuff that is up in the hierarchy, and that's what I'm trying to do.
Actually, in this scenario, what happens if you simultaneously commit changes to different parts in the hierarchy that depend on each other? Will the build go right away, say, I'm going to independently build both bits and then fail on the second one? Or will it kind of like wait for the dependencies to be built?
So the way TeamCity does it, and I think this depends a bit on the actual logic of each continuous integration system, and also it's configurable, so it depends a bit on how you tune it. Let's say, for instance, in this case, I make changes to both of them. TeamCity in particular will actually schedule 3 builds. It will schedule 1 build for the backend and 2 builds for the super app, because what it will do is, okay, I need to build a backend, and as a result, I need to rebuild the super app, and then also I need to build the super app with the new change. So it's going to build super app twice, because it's going to build it first in the previous version. It also keeps in mind what version it needs to build. So when it builds it the first time, it actually ignores the second commit, because it's going to build it just taking into account the change that you made to backend. So then that might work or not. And then if that works, then it will run the second one with the new change that you did. So it might actually happen something that says, well, you know, the change that you did in backend, that is fine, that works. But the change that you did later in the super app, that doesn't work. So you get that feedback. If you configure it differently, for instance, you could configure it so you don't have 2 builds in the queue for the latest module, that you only have 1. But then if that fails, you don't know if it failed because of the change that you made there, or as a side effect of the change that you made on the dependency. So it has pros and cons. One is more informative, but it runs more times. The other one is better performance, but it gives you less information. Yes?
I'm sorry, I didn't understand something. When you say mentioned before that there was a pending build on the TTP backend, where does this pending build come from?
Yeah. So,
no, right after.
yeah, the explanation comes here. So when I'm building, if I make any change, I'm going to make a change to some version that's going to trigger.
No, it's not that far.
Sorry. Do you mean this?
Yeah, that one.
Yeah.
Where does the pending one come from? Because I've seen the trick of avoiding the build.
Yeah, it comes from there. So when I tell TeamCity here to ignore the commits made by the build agent user, or by the user that I use from the CI system to update the config file, then what happens is that TeamCity, it will not trigger a build, but it will know that there is a change. So then TeamCity shows it as pending change, because it says, I know that it's a commit, I've seen the commit, but I'm not going to run it. The problem is TeamCity doesn't really know that it was TeamCity through the build, the one that made the change. So unless you stop it, TeamCity is going to keep on rebuilding itself.
Did you ever think about maybe the digital kind of have hashes of the version is implicit, so you always know, so let's say you make a change and you say, okay, I'm going to make an artifact based on the hash, and then I can index it based on the hash. I don't have to have this loop where I come back and put an explicit version. The in-between version could just be the hash key, and in that way I have a, for this hash key I know what the source code is. So in that way I don't have to make this look back. I mean,
You could do it. I don't know what will happen, because every time you rebuild, you're going to change the config file. So, and you're going to commit that, which means the hash is going to change.
No, I mean, the idea is not to have a version, not to have a version explicitly saved inside, so you're not committing another file, but make changes, but you have a hash key that's associated with that change, because you don't have to know, and then you can associate your artifacts with that hash key. So for this version of the code, this is the artifact.
Okay.
I don't have to go back and then, you know, in that way you can same way that Git works, that you can do your dependencies up the tree and then you get the final hash. I mean, of course you can explicitly version them at the end, as you have new versions, but you can always avoid the point where you have to explicitly version and then you have to commit back. And then you can change it. So you get into that loop, you break that loop by just not doing that, by using the implicit version, which is the version of the hash.
But you might still need to distinguish between the source code, like hash revision, and the build that you might repeatedly do if you run into errors on your build machine. That you kind of like fix, or there were something went wrong, which actually I think happens more in C++ than in Java. But if you figured out your artifact is broken not because of the source code, but because of the process of the build itself. So how do you go to distinguish a repeated build from?
Well, I mean, in that case, I mean, you discard the builds that are unsuccessful. I mean, you have a dependency, and you say, okay, I want this version of the artifact, and our version is the version.
Yeah, but I guess you get in all sorts of trouble if you try to kind of like the build went through and you put something into the artifactory, and you later need to replace it but not change the version.
And Artifactory will probably not let you do that. At least in Java, it doesn't let you publish two different binaries with the same version, because the versions are meant to be unique. Right. In any case, I think the biggest problem would be, how do you refer to the versions of your dependencies? I mean, you could refer to the hash, but then if there is a new dependency and you need to refer to the new dependency, then you need to change the hash that you're referring to. So you're making a change anyway.
Yeah, I mean, because it's a common, you lose. You kind of want to go back to that.
Yeah.
You're not changing the change you're talking about is not in the origin, it's in the dependence.
Exactly.
So the dependence would be need to rebuild anyway, so you can make a change.
Yeah, but then
you're going to figure out the latest hash and not all of it.
Yeah, or if we go back to that situation where I need to rebuild the system as it was 1 month ago, how do I know what versions of the dependencies that particular system was built with, unless I save them? So when I have in here, if I have my two modules and I want to go back to the version a week ago, and I get this from the repository, I get the source code from the repository, and I build it, when I'm building this, how do I know which version of that one I need to pull from Artifactory?
Well, from the hash.
But then I need to store the hash.
Yeah, you need to. I mean, if you aggregate the hashes, you've lost the individual one.
Yeah.
But the point is, with your approach, a component has to know about its own version. So you need to change a file in there after the build, where with the hash approach, you're only referring to your dependencies. So
True, but then you're still making a change in the file.
yes, but you don't run into the pending problem because you're not modifying yourself after the build.
You are, because you need to store the versions of the dependencies that you're using. Otherwise, if I check out this code from the repository in a month from now, how do I know which versions of the dependencies I need to download to build this?
I do this before the build, but you're right.
Yeah.
You need to do it after the build.
Yeah, otherwise in a month from now, when I take that out from the repository, it's going to build it for the latest of a month from now, not the latest today, which is the one that I actually need. Yes?
I can't remember how Subversion does it, but Pérez, that's what we're using, has global change numbers, so global unique change number. So with every commit, we have a change number that is a consistent view of the whole code. So you could use this as a version of it.
You could, and in fact, we did that at the beginning. The problem that we face is that sometimes, especially in the integration tests are sometimes a bit flaky, and they might fail for no reason at all. And then we want to rerun it. But then when we rerun it, then it's actually going to make a run with exactly the same version number. And then that sometimes created a bit of confusing situations. So in the end, we decided to use the build number as opposed to the global revision number. Although, depending on your situation, it might be that the revision number is actually a better choice. So this all that I'm saying is a very specific case to the problem that we had in our team with our constraints. But actually, in your case, you may need to, or you may want to change things a bit. Okay, so let's continue with the next problem, which is after we have fixed the unnecessary rebuilds, then going to a phase to have a problem with the necessary rebuilds. Now, if you remember how we fixed this pending situation, let's reverse the problem. Let's think that the executable is the one that has a pending flag, and I'm making a change in the backend. Now, in theory, what should happen here is I rebuild the backend, I make a new binary, I put it in Artifactory. After that, I trigger this build, I consume that new binary, I run things, produce a new executable. The first part is going to happen exactly as we said. Now, when we get to the second part, when this build starts, it's going to do this check that we talked about. And it's going to say, who was my last committer? It was the build agent. Yes. Then don't run anything. So now we need to rerun this build, and because of the changes that we did, it's not rerunning the build, which again is very unfortunate. And the way to fix it is to make this a little bit more complicated again. It's a bit of a trade-off, this whole thing, because you can have it working, but because of the existing tools weren't thought of this, you just need to keep plugging holes here and there. So in this case, what we do is we do the first check. If the committer is an actual user, it's not the build agent, okay, that's good, proceed, build that. If it is not an actual user, then check the dependencies. Do I have new dependencies? If I have new dependencies, then I need to run this. If I don't have new dependencies, or in other words, if my dependencies are up to date, then don't run the build. And now this way, I'm checking two things. I'm checking whether I used to change the module, or whether my dependencies have been changed. In any of those situations, I'm then going to rerun the build, which is what we want. In our case, because all this was a little script, then the TeamCity build configuration didn't change. We just needed to change the script over there, which means we still have only 4 steps. And with that, we're going to go to the problem that you mentioned. Let's imagine I make a change to the code. That triggers a build. Now, it triggers a build. That build could run immediately, or it could just be put in the queue, waiting for something else to happen, right? Okay. While that is there, somebody else makes another change, this time to the POM file, which is in Maven the config file where we store in the version information. Then the build finishes, it stores a new binary in Artifactory, and then it tries to update the POM file in Subversion. And at this point it fails, because it realizes the POM file that it has built with is not the latest version. So then when you try to commit that, you're going to have a conflict, and it's going to say, no, you need to update your local copy before you're committing. Unfortunately, this is not quite a problem that you can entirely fix. At least I haven't found a problem, I haven't found a way to fix it, but it is a problem that you can try to mitigate. Now what you do in our case, what we did is we added an additional safe check in here. So at this point, when we think we're going to go ahead, we check if the POM file is actually up to date or not. Because if it's not up to date, then that build is going to fail. So there's no point running it. So then in that case, we just skip it. If it is up to date, that's kind of safe and we can go ahead. And I said, this doesn't completely fix it because this check is done at the beginning of the build. But it could happen that you make a change to the POM file halfway in the build. So then when I try to commit the change at the end, it still fails. So sometimes it still happens. And I don't think you can completely fix it, but at least you can alleviate it, and hopefully it won't happen too often. And when it happens, you just rerun it, and then you should go ahead with no problem. And again, in our case, because we just changed the script, then we don't have any more steps in the build configurations. It's just changing that particular config file. And now with those changes, it works. I promise. We had this, and we were very happy with it. And when I'm working now at the moment, we have a similar thing, and it also works. And we're mostly happy about it. There are some issues, but nothing is perfect. And that's it. Now, with all that complications, is anybody actually thinking of implementing anything like this? Oh, okay, that's good. I've done this talk a few times, and many times when I ask at the beginning, they say, yeah, that sounds good. And when I ask at the end, they go, no, that's too hard. Not worth it. I'll build everything every time. Good. Now, to me, this is the most interesting part, so I hope I didn't consume all your energies up to now. If so, maybe we need to do a little break and get some cookie, sugar, pump or something, because I think this is the really interesting bit. I've talked about how, at the beginning, the decision of what to break down is very easy. You only have one build, you break it down. And then if you only have a few builds, it's kind of easy to spot which one is the one causing you a bottleneck, which one is the one slowing you down. So you go, this is the one that I have to break. Now, when you have 20, 30, 50 different build configurations, 50 modules calling each other, and your build is slow, how do you know where to change things? This is a performance problem. It's a performance of your build. It's a performance problem of your build pipeline. And like any performance problem, the first thing you need to do is measure things. So you need to know how your build is acting and where things get stuck before you can consider making any changes. So then this whole part of the talk is going to be about things that you can measure and how to act on those things and how you can establish some thresholds for you to decide when you need to make changes and where you need to make those changes. So I'm going to present a real case scenario. This is the system that we had when I implemented this whole solution in TeamCity, Maven, etc. It looked like this, basically. Just to explain a bit what it was doing. It doesn't really matter what it does, but I think it would be easier to have a little bit of background. The bits on the end, the WAR file, remember, those were the packages for a web application that you can put in a container, and then that just works. All the bits in the middle, they are jar files, which is basically libraries or the compiled binary objects of C. And then this thing here is what we call a parent POM, which is a parent config file. And that module only has a config file, and it's just a config file that has common config parameters for everything else. This is a login library. I drew it like this just because pretty much everything depends on both the parent POM and the login library. And I thought drawing arrows to each single bubble was going to be too messy. But well, just bear in mind that pretty much everything depends on these two. And then the rest of it, the arrows, is indicating the triggering. Yeah?
For each arrow, you add the dependency in the TeamCity?
Yes.
It's painful, no?
Yes and no, because at the end of the day, you don't create new modules every day.
The thing is, you kind of redoing the job of the building system like that, right? Because you're just telling your CI which thing they want.
Yes.
It's not more efficient or like just requires more code and
It's true, and in fact, where in Mendeley, where I'm working now, we actually build this dependency tree automatically from Maven. So there is one big job that scans all the different projects and all the different POM files from all the different projects, and it will build a dependency tree, and then it will go to Jenkins, because in this case we have Jenkins, and wipe out all the job configurations and then recreate them with these dependencies automatically. Right? When I did this in my previous company, we didn't have such a sophisticated thing, but because we only created new bubbles every now and then, we didn't mind having that overhead. It is true that it's a bit of a duplicated effort because you have the dependency information in the config file and then again the dependency information on the build system. But it's a trade-off that we accepted in that case. Right, so here's where the analysis begins. One of the first things that I checked is where we're making changes, right? So I checked for a period of 2 months. I took logs from Subversion for those 2 months, and I checked where the commits were going. And it turned out 28% of all changes went to that particular module. So that's over a quarter of all changes in a period of 2 months. Now, when you think about it, if you're working on a particular project, you typically work on related things day after day, which means it makes sense that on a particular period of time, your changes tend to concentrate or to cluster on particular modules. So it makes sense that your changes should concentrate on an area. Now, the interesting thing is, if that module is rebuilt 28% of the times, that means its dependencies are also rebuilt 28% of the times, right? So then in 28% of my commits are going to rebuild these 3 modules. Okay, then I check the next one, the next most committed file, or module, sorry, and it turned out to be that one, about 20% of the times. Now that means its dependency is going to be recompiled roughly half the time, 28% because of one, 28% because of the other one. In actual terms, it would be a little bit less because sometimes the build will fail. If it fails, then you don't trigger the only ones. But well, it's a good estimation of roughly how often you are rebuilding each thing. Now, if you apply this process and calculate the statistics of how often are you rebuilding each particular module, then you can have kind of a heat map of what kind of modules are being rebuilt a lot and what kind of modules are more stable and you don't rebuild them very often. And then you can apply colors to that and you get something like this. And this already gives you some interesting information. For instance, obviously the bits at the end of the pipeline are the hottest ones. And it makes sense they are hotter because whenever you change anything anywhere, eventually you're going to rebuild an executable. So it makes sense that those things are the hottest. And then again, your basic configuration and your login library, those are rather cold things. They're very stable because usually you don't change those things very often, which is good. And then you see relationships between colors. For instance, here, these two. This is where the laser pointer actually comes in handy. We can see that the one on the right is significantly warmer than its dependency. That means that we are rebuilding this one more often than the dependency. Now, every time we change this, we rebuild this and that. That means that if this one is warmer or is rebuilt more often than the previous one, it's because we're making changes here. It's not because we're changing the dependency, right? So this color is telling us something about how often we change each of them. If we do the same thing, for instance, with these two, we see they are roughly the same color, which means they're being rebuilt roughly the same number of times, which means the reason we rebuild this is not because we change it, it's because we change its dependency. We can see this, that, this here, they all roughly have the same color, which means the reason we are rebuilding all this stuff is because of this one. So maybe that one has too much information in it. It has too much functionality. And that's why so many things depend on it. And that's why I have to change it so often that I have to rebuild a considerably large part of the system because of that. So that's giving me something. That's giving me maybe there is a little bit too much on that bubble. Okay, let's add another dimension to this graph. I'm showing the rate of rebuild. Let's also show how long it takes to rebuild each of those things by, for instance, changing the size of each bubble according to the build length. That looks like this. This is actual numbers. I actually took all the build times for each particular build. Now, again, obvious things, this bit's huge because they do end-to-end integration tests. They have to deploy things to a web server and then do end-to-end tests, etc. So they take very long. The configuration build is tiny because it doesn't do much. It just checks that the syntax is correct, and if so, then it goes in. Now look at this one. It's not super big, but if you compare it to the ones around, it's bigger than the ones around. So that's giving weight to the idea that maybe that particular bubble is doing too much. Now the interesting thing about it is that usually when we decide that a module or a class or anything is doing too much, it's because we look at the code, we do a qualitative assessment of what it's doing, and then we may decide, no, I think it's doing too much. It's a bit of a subjective thing. We can achieve consensus, but it's a subjective thing. Here, we don't know what it does. We're just taking our numbers. And the numbers are telling us, well, maybe that thing is doing too much. Now, this is a quantitative assessment. And it helps you argue a bit better. If you have to decide which one we break down, well, the biggest one. That's the first thing you can start measure. Now, the problem with this is relative terms, right? So yes, we know this one is bigger than the other ones. If we need to break something down, we break down that one. But then the question is, do we need to break something down? Is overall the build fast enough or not? That's when you come to the other metrics. Now, it's going to look a bit like formula-ish, pseudo-mathematics. It's just bear with me. I'm going to define a few metrics, a few things that we can measure. The first one, the build time, which is how long a build takes to run, right? And I'm going to call that BT. In our graph, that will be the size of the bubbles. Then I'm going to define another formula, which is another variable, which is a change rate, which is how often we make a change, right? Now, this is where it gets confusing, so please bear with me. The change rate is not the color here, right? It's the percentage that I showed at the beginning, is that bit. That is the change rate, is how often we make changes to that. We get these from, for instance, the subversion of the Git logs, okay? If we have the build time, which is how long it takes, and we have the change rate, which is how often we make changes to it, not how often we rebuild it, we can, on top of that, define other variables. Let's imagine 3 builds, like this. We have A, B, and C. Both B and C depend on A. We can define the impact time of A as the time that it takes to rebuild everything that I need to rebuild when I make a change to A. So in this case, it will be the build time of A plus the build time of B plus the build time of C. Right? Okay. Now let's imagine that from here, we actually have more builds hanging. Then the impact time, the total impact time of A is going to be the build time of A, how long it takes for this, plus the impact time of B and C, which is how long it's going to take to clear up things from B and for C, right? So basically, this is what we're talking about. The impact time of A is the build time of A plus the impact time of B and the impact time of C. Why do I say serial execution? Well, if you have a quite powerful continuous integration system and you can run builds in parallel, then that thing is not going to be exactly true because you're going to build these two things in parallel. So actually, your total impact time is going to be whatever maximum it is, right? So then if you need to build, if you can only build one thing at a time, then that's true. If you can build things in parallel, then it's something more like that.
I think there is another problem with that. You have these write bulbs that are making the executables out of several nodes. So if you have an execution thingy there, which will tag B and C together, you will count that twice.
Yes.
But you will build it twice, right? No?
It depends on how you have configured your continuous integration pipeline. It will run twice or not. In our case, it did. In some of the cases, it will not, because you will just put one build on the queue and just wait until all the parent changes have been done, and then do it. So it depends a bit on your configuration. And to be completely fair, even these, in practical sense, it won't be exactly true at all times, because you may have the ability to run things in parallel, but you usually have a limit of how many things you can run in parallel. Maybe you have 5 builders. The moment you get 6 things on the queue, then you only run 5 of them in parallel and the other one waits. So then the actual measure is not going to be that, it's going to be a different number. But at least it gives you an approximation, it gives you a baseline to work with, right? So, this is the build time that we talked about before. To make a difference between build time and impact time, build time is what we see. The impact time would be these times being accumulated as we go back in the hierarchy, right? So actually, the one module that will have the highest impact time will be this one. Because whenever we change this, we have to rebuild everything. So that the impact time of this is going to be huge. It's going to have everything accumulated. Okay. I said this bubble here is the one that is going to have the highest impact time. Does that mean that's the biggest problem? Well, not necessarily, because I don't run it very often. So then I need to weight the frequency of change with the impact of change. So then that's where I come up with the weighted impact time, which is basically one thing with the other. You just do that. And then you get the relationship. And then this is where you start to get interesting things, because these values, if you calculate it with every single build, then you're going to see the one that is on average your highest impact. And then if you put them all together, you get the average impact time, which is the weighted impact time of all of them. And then this is a very interesting metric, because this tells you, on average, whenever you make a change anywhere in your system, how long does it take to clear? Right? And this is where you can start to establish some thresholds for your, the speed of your continuous integration system. Now, for instance, maybe you're just worried about having a consistent development experience, right? You want to work in an effective way. Then you can work on the average impact time. Just set up a limit for the average impact time. Just say, for instance, I want my average impact time to be no more than 20 minutes, or no more than an hour, no more than half an hour, something you can find realistic. And then the only thing you need to do is keep on measuring. The moment you go over that, then is when you can start checking all the other variables and say, okay, this has gone too long, we need to make it shorter. What can I change to make it shorter? And that's when you analyze all the other variables and see which one is the candidate to give me the most benefit to make this shorter. That's an example. There's another one. For instance, maybe you don't worry that much about your average, but about your maximum. For instance, because you have an SLA. If you have an SLA of whenever there is a bug, you need to fix it in 3 hours, then your safety measure would be, okay, then maximum, I need to be able to rebuild everything in 1 hour. Right? So in the worst case scenarios, the build is not going to take longer than this. That's another measure that maybe you want to approach. And again, you just establish as a threshold, you keep on measuring, and whenever you go beyond the threshold, then you check all the other variables to see what you can break down and how you can make it faster. Or maybe you just want to worry about the impact time of some particularly critical components, right? Maybe, rebuilding your interface is not a big deal. If it takes long, then fine. But rebuilding your security module, you want to be able to rebuild that fast, just in case you need to fix something, right? Or your payments gateway, or your login, or anything that is critical to your application and that you want to be able to react fast. Be careful though, this one is tricky. Let's say, I can't point. Okay, let's say this one here is a critical one for you. And you want to say, I want to establish a threshold for the maximum impact time of this one. So whenever I make a change to this, I know that I'm guaranteed to have a full build in less than X minutes or hours or anything. It might be that you have a problem here, not because of the code in this module, but because of the code in one of its dependencies. Now, if you have to change if you have to make a change in a dependency to fix this, then the impact time of this is not the variable that you're after, it's the impact time of its dependencies. But then if you keep going back, then in the end, you're just going to get to the impact time of your root dependency. So then establishing a maximal threshold for a particular bubble is going to be a bit tricky, and you need to be very careful with the dependencies to see if this is the one that you want to measure, or one of its dependencies is the one that you want to measure. And again, this is a conversation that you need to have with your team, etc., etc., etc. Now, there is a very interesting side effect of all this, which is we're saying we are breaking down our builds, or we're breaking down our system into modules depending on how fast they build. But how fast they build depends a lot on where I'm making changes, right? This particular structure of hotspots, of hot and cold builds, is because I'm making changes to particular areas. If I make changes in other places, then maybe the distribution is different. That means that the optimum architecture is not a fixed thing. It might change over time. Maybe this month we're changing all of this area, so then we want to break it down so this particular area is fast to build, but in 6 months' time, the needs change. We're modifying that area, and then I need to restructure my whole build to adapt to that. That means our architecture is going to have to be a bit more dynamic. There is no one single idea of good architecture, and today's optimal architecture might change tomorrow. It becomes a bit frustrating sometimes when, if you're doing this, if you realize that your build is slow, and to make it faster, you have to make some changes, which basically means undoing what I did 3 months ago. And you need to understand that that's okay, because you are adapting to change. You don't have fixed a temporal thing. Now, how many of you think this is useful, or this is something that you could get on, measuring these things, acting on the metrics, etc.? Yeah? Okay, good. I like it too. The problem that I find is I don't know of any tool that can make these calculations for you. Right? All these things that I did it manually. I downloaded all the logs, I checked the data, I put it into a spreadsheet, and then even the colors, I had to do a trick, do a gradient with Excel, and then basically copying the color and then pasting it on each particular bubble to be able to do this presentation. And the problem with that is that it takes a lot of time. So then it might be okay if you don't need to be too reactive. Maybe you can do this exercise once a month or once every 2 months and then make a decision. But if you want to be more reactive and you want to be able to do this more often, then you need the tool for it. As I said, I don't know any, but the good news is it's not too difficult to do it because the information is available over there. The CI system gives you APIs to gather data from it, etc., etc. And I actually started a bit of a toy project to do this. I call it Build Hotspots. That's the URL in case you want to take a look. I was considering doing a demo. However, as Carlos might tell you, actually, the demo is very slow. So I thought or probably not. If anybody wants to see it, actually, you can download it and try it. At the moment, it only works with Jenkins. It can do the heat map. It can tell you how often you rebuild each thing. I don't know what that was. But it cannot tell you the size. That's something that I want to do next, right? So there are a lot of things that I want to do following. But well, it's something that can be done if you find it useful. Yes?
Where does the graphic come from? How,
This one?
yes, right. How do you produce the graph?
So in this case, what I do is, at the moment, it can connect to Jenkins. So I download the build data from Jenkins. Its build configuration has, in Jenkins, what is called the upstream.
I'm more interested in how to lay out the graph. So I'm thinking about graphers that can lay out the graph, and you can easily change the colors and sizes of nodes.
Changing the color is relatively easy because you just need to calculate the frequency, and then you calculate a gradient between red and blue. That's simple. Same with the size. Well, I haven't done the size yet, but I would say that's relatively simple. You just have to define maximum and minimum, and they do a gradient. The layout, that's the difficult part. There is a kind of an algorithm that a friend contributed with. I haven't done that part. I'm not exactly sure how it works, to be honest, but it does sort of lay out things. If you have a very big one, still it's not going to work that well. What you can do, though, is you can actually grab the bubbles and move them manually. And one thing that I like to do is once you do that, actually save that, so then the next time you load it, it remembers where each bubble should go. But yeah, it doesn't do it at the moment. So once you load it, you reposition them and don't touch them, basically. And yeah, I wanted to close with an image of this. This is a driving wheel from a Formula 1 car. It's, as you can see, quite complicated. It has a lot of buttons and displays and everything there. Only the wheel costs about $50,000 to make. The reason it has that is because, well, Formula 1 cars, they are one of the best performance vehicles that exist. It's incredibly complex and incredibly fast. And the reason they're so fast and so performant is because they measure everything in the car. They measure the temperature in the wheels, they measure the aerodynamics, how much pressure you have on each side, how much the weight of the gas itself, and how after you are consuming gas, then the weight distribution of the car changes because you have less content in it, etc., etc., etc. And then all that information can be displayed there, and then the driver, as he's driving, can use that information to make decisions and change things. Now, the reason they do that is because they measure a lot of things, because they invest time, effort, and money on making sure they have the tools to be able to adapt. So the corollary from here is, if you want something that is fast, you need to spend time, effort, and money on measuring things, on building the right tools, and on learning how to react and how to use those tools. That's pretty much it. Thank you very much. Please remember to rate the talk on the mobile app if you have it, and if not, then in the box with the colors there. If you have any questions, please, I think we still have a few minutes for that, and if not, then, well, thank you.